Hi, in this video, we want to take a look at exploratory factor analysis using Python. Okay, so factor analysis is where we have under the hood latent variables that we believe are driving observed variables. So for example, let's say that we're looking at academic ability. We have mathematics tests and we have an English test. So we believe that there is an unobserved, like under the hood, latent variable that connects to mathematical ability. And that mathematical ability factor is driving the observed results of the math test. And there's another factor for English that is driving the results of the English test. So what's going on is that there is some unobservable variable that we can look at, like how it influences other things, but we can't directly measure it. And that's why it's called a latent variable. Now, this is very common in psychometrics. So, most of the time when we're talking about things like this, we're going to be talking about like personality, and we're going to be talking about intelligence. Now, for this example, we're going to take a look at privacy. So a person's attitude and beliefs about privacy. And the example that I'm going to work through is taken from datacamp.com and the MPsychoR package, and then the help documentation for the function that we're going to be using, FactorAnalyzer. Okay, so there are two types of factor analysis: exploratory factor analysis and confirmatory factor analysis. Exploratory is we don't really know what exactly the under the hood variables are. We don't, we have an idea of what's going on, but we haven't really made it concrete. We don't have something precise. We don't know the relationship between observed variables and latent variables. Now, confirmatory factor analysis is where I already believe, I already know, I have a hypothesis, I have a modeled relationship between observed variables and latent variables. And what I want to do, I want to fit that model given my data. Now, the ways that we can fit this is either with the frequentist point of view or the Bayesian point of view. What we're going to do here, we're going to do exploratory factor analysis, and we're going to do the frequentist point of view. So we're not going to touch confirmatory factor analysis. We're not going to touch Bayesian fitting in this video at all. All right, so if I'm going to be doing factor analysis, of course, I'm going to need to load my data. So let's go ahead and get pandas going. I'm pressing F9 as I work through the code. In the lower right-hand corner shows the execution. And there's only one plot in this video, and it's right here. But when I recreate it, it'll be here for us to look at. Now, I'm going to need to pre-process my data using sklearn. And for the visualization that we're going to create, I'm going to use Seaborn. And then I need the FactorAnalyzer function from the FactorAnalyzer package. Okay, so now let's go ahead and get our data set. We're going to use the privacy data set from the MPsychoR package in R. And so there are two classifications, two types of variables about privacy: advantages and disadvantages. And we're going to be looking at that data set. Now, next thing I want to do, I want to scale my data set. Why do I do this? Okay, so if I don't center and scale my observed values when I do factor analysis, then the columns that have greater standard deviation will have more influence in my model. That may be good, that may be bad. If I want to make sure that they each have equal influence overall, I want to rescale things. If I don't do this, let's say I'm in a situation where all my columns are standard deviation 1, except for another one that's 100, and we have, let's say 10 columns total, then what will end up happening is that a column with 100 standard deviation will have disproportionately more influence on the model than the others. That may be good, that may be bad. You have to decide for yourself. But if you don't know, rescale your data. All right, now the output from the preprocess function is not in the format that we can use yet. So I'm going to go ahead and use pandas to convert it to a data frame. Now I want to take a look at the correlation between my observed data. And here I get the correlation matrix. Kind of hard to see, but here it is. Maybe I'll regenerate it. All right, so here we go. We can see there's a correlation. We can see that we've got 10 columns, 10 rows because it's a correlation matrix coming from data with 10 columns and 10 rows. All right, so now let's go ahead and plot the correlation. So here we're going to use Seaborn's heat map to do this. And here in the upper right hand corner, we can see that the first 6 columns are highly correlated and the last 4 columns are highly correlated. So this leads me to believe that we have 2 factors. One factor is corresponding to the first columns. One factor is corresponding to the later columns. And these correspond, if I look at the data set, to advantages and disadvantages. So let's go ahead and proceed, and let's make the assumption that there are 2 latent variables under the hood. All right, so what I'm going to do when I use the FactorAnalyzer function, I'm going to fit a model where I have 2 latent variables. And I believe that one corresponds to the advantages, the attitudes of advantages in privacy, and the other one corresponds to the disadvantages in privacy. And I need to choose a rotation. I'm going to use Varimax for this example. Okay. So now what this does, this creates a structure of the model, but doesn't actually fit it yet. The model is not fit. It's just the type of model structure that we have. If I want to actually fit it, I need to use the .fit to get that. So I go ahead and I fit it. Okay. And so now let's take a look at the loadings. All right. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 rows and 2 columns. So remember, our original data had 10 columns and we have 2 latent variables, and that's how we're getting here. Now you'll notice that I've got positive on the first 6, negative on the last 4, negative on the first 6, positive on the last 4. And you'll notice that the ones that are positive are of much greater magnitude, an order of magnitude greater. Okay, so here, this looks like this is involving a lot of like the advantages mainly of privacy, and here are the disadvantages of privacy. Okay, now we can get, when we use FactorAnalyzer, we can get the original correlation matrix back if we wish. We could just, take it from the original data, but down the road it might be nice to pull it out. So an easy way to do that. Now let's go ahead and get the rotation. So the rotation is what actually makes factor analysis between like principal components and factor analysis. The difference is really the rotation. And so let's go ahead and take a look at the rotation matrix. Okay, so we only have 2 factors, so we can present this as being on a plane. And since it's on a plane, I can represent it with a 2x2 rotation matrix. Okay, so this corresponds to, remember, I've got cosine on the diagonal and corresponds to sine on the off diagonal for the X and Y rotation aspect. So this is about 21 degrees. So, cosine close to 0.1 is close to 0 degrees. All right, so now let's go ahead and get the commonalities. And so we can get the values here. Now we can get the eigenvalues. Now the eigenvalues, we're going to get 2 different types. We're going to get the original eigenvalues, and we're going to get the common factor eigenvalues also. Now we can calculate the uniqueness given the factor loading matrix. And now I can use the transform to get the factor scores for the new data set. So if I had new data coming in, let's say, so I have fit this model, and then someone comes up to me, hey, I have new data. I want to know what's going on with these in terms of the latent variable. I take the new data that is the same test given to different people or another administration to the same people, and then I drop it in, and I can get the factor scores for those subjects. All right, so if I want to do exploratory factor analysis with a frequentist technique for fitting, the FactorAnalyzer function is a good way to go. It's got a lot of nice features, it's capable, it's powerful. And it's pretty easy to drop in new data. So after I fit a model, if someone comes up and gives the test again, or something, then I can take that data very easily and get the factors for those subjects. Well, that's all I've got for you. Take care and goodbye.